In this video, I'll explain about the timers and counters of ATmega16 microcontroller. So we will be discussing the basics of timers and counters, how to configure, what are the different applications where we can use the timers and counters, and programming. The timers and counters are used to count the clock pulses. This is the clock input that is applied to a timer and it will start counting when it is enabled. So it will count 1, 2, 3, 4. So in each cycle, the count is incremented by 1. The count is stored in the register which is associated with the timer and counter module. The timer counter module is part of the microcontroller chip itself. It's a peripheral of the microcontroller. Now let's understand the difference between timer and counter. The same module, the same peripheral can be used as a timer or as a counter. When the peripheral is used to count internal clock pulses, then it is called a timer. So in the case of timer, the clock is coming from the microcontroller itself, and or it is used to count the internal clock pulses. It is called a counter when used for counting external clock pulses. So when clock pulses are coming from external device or external source, then it is called counter, or it has to be configured as a counter. The same peripheral module can be configured as a timer or counter. This is the internal structure of the timer counter module. It has different registers, different clock options. Now let's understand the different registers of the timer counter module. So the first one is TC and T0. The TC and T0 is an 8-bit register which is used to store the count value. So if we have this timer and we are providing some clock pulse, so the counting information, number of counts are stored in this register. So here we are discussing the 8-bit timers, 8-bit timer module. There are other timer modules available with the ATmega16 microcontroller, but here we are discussing only the 8-bit timer module. So this is an 8-bit register which is used to store the count value. For example, if current timer count is 8, so the register value will be this one, 1000 and 0000. Then we have output compare register, so we can generate or we can produce some signal on a certain microcontroller pin when the count matches to some fixed value. So that's an additional feature of this timer counter module that can be used. So if we store some value in the OCR0 register, it is continuously compared with the content of TC and T0 register, and if it matches with the content of OCR0, then a signal can be generated on the OCR0 pin. So it can be used for certain applications. We are not We can also prescale the clock. We can divide this clock by certain number. Okay. So we can divide this clock by a prescaler value, fixed prescaler value. So let's say we have CPU clock of 8 megahertz and we want to divide it by 8. So we can select an appropriate prescaler from the available options. So in this case, this input clock will be divided by a certain value, and then it will be then this new clock pulse will be counted. So in the case of TC and T0, the minimum count will be 0 and the maximum count will be 255 because it's an 8-bit register. After 255, the count will become 0. So during this transition process, this overflow flag will become 1. So this T0V for timer 0, this will become 1. So we can identify the end of counting cycle. Then we have this, we can also generate interrupt at the end of counting cycles. Then we have TCCR node register. So it is used for timer configuration. Here we are exploring, or we are using timer for delay operation. So for delay operation, it is used in normal mode or mode 0. So for to configure timer in the mode 0, these two bits in the TCCR node register should be 0. So here we have to write 0, and here we have to write 0. Okay. So the timer will be configured in normal mode. These are the different modes, the PWM mode, CTC mode, and fast PWM mode, etc. that can also be used. And apart from that, these are 3 first bits which are used to set the prescaler. These are the different options for prescaler. For 000, no clock source, timer counter will be stopped. For 001, clock, no prescaling, 010, clock divided by 8. And for this option, 64, 256, 1024. So these are the, we have different prescaler options from no prescaling to 8, 64, 256, and 1024. So for example, the CPU clock is equal to 8 megahertz, and we have selected this option 010. Then the timer clock will be divided by, the timer clock will be 8 megahertz divided by 8 equal to 1 megahertz. So based on the requirement, we can select the appropriate prescaler from the given option. And the prescaler, these are the 3 bits corresponding to the prescaler value. If we write 000, then the timer counter will be stopped. And if we write 001, there will be no prescaling. The same CPU clock will be applied to the timer.